All right, PoA, let's talk about part 6. This is all deciding whether or not these actually represent functions, which means we should probably take a second and establish what in the world it even means to be a function. Lots of ways we can explain it, but the best way I heard over and over again is one input maps one output. It's predictable. You can tell what's going on. If I push button X, I should know exactly what button X is going to give me. If I push button Y, I should know exactly what Y is going to give me. Like, I shouldn't push Y and get like a cupcake, and then push Y again and get like frosting. Although those sound delicious together, it's not a predictable thing because whatever you push, you should always get the same thing no matter what. So we can look for that in the graph. So this is kind of like my input, this is kind of like my output. So what I'm looking for is if I push like -1, do I know what I'm going to get? Is there going to be a situation where I push -1 and I get a -5 and then I push it again? And that's the key. I push -1 again and I get a different number that's not -5. And now in this case, that doesn't happen. I push -1, I get -5. I push 0, I get -3. I push 1, I get 0. I push 2, I get -3. I push 3, I get -5. This one actually, boys and girls, is a bona fide function because at no point am I going to be pushing one of these numbers on the in and getting two different possibilities on the out. Now, I know what some of you guys are thinking. You're saying, hey, wait a minute, Mr. Collins. There's a -5 and there's a -5. There's a -3 and there's a -3. Okay? How about that repetition? Doesn't that matter? My answer is simply no, it doesn't matter. And here's the reason why. Think of this like a vending machine. Is it a working vending machine if I have like Cheetos hooked into two different buttons? Yeah, so two different buttons give me the same thing, but that's not like a surprise to us. Like we saw the picture written on the vending machine where if I push this button or this button, I'll both get Cheetos. That's cool. What's not cool is if I push that button twice and get two different things. So this is actually a function. And I'm not going to write out the explanation too carefully, but again, what I want to point out is if I'm looking at my table, there's only one input for every one output. So I can say this a couple different ways. Whoa, back to my pen. I can say this a couple different ways. I can say there's no repeated inputs, but really, it's always going to be one in going just to one out, no matter what. So let's take a look at the second table. And I like the way I drew those arrows. I'm going to try this again. So we have a -2 going to an 8. Well, look at this. -2 is listed twice. So -2 also goes to -1. I know there's two of them, but really it's the same button. So if I push 2, I can get an 8. If I push 2, I can get a -1. That's enough to say it's not a function right now. Since there is a repeated input, we have one in actually going to two outs, which is no good. Like one in going to two different outputs, not predictable, not outable. You don't know what's going to happen, i.e. no function. Let's go talk about this graph. This, I'll tell you right now, is going to be a non-function. Here's the reason why. This is my input axis. Here's my output axis. So if I'm looking at this point right here of the input, I could go to three different possibilities. If I look right here, I can go to two different possibilities. Because I have one in going to more than one out, that is a no-go, it's not going to happen, not a function kind of thing. And I could even say that it's going to be kind of like what I wrote up here. I have one input going to multiple outputs. In other words, one x goes to more than one y. But this graph is actually pretty good, and let me kind of show you what I mean. If this again is my input axis, okay, if I look anywhere on this input axis, I don't have more than one y I can go to. Now granted, it changes constantly, but I'm only going to one y period. So this guy right here by far is a function because I only have one x for every one y. One in for every one out. I'm just going to use x and y because it's a little bit shorter. Here's some very familiar maps. Let's talk function, no function here. I think this guy is a no-go, no function, because look, I push C, I could get two different things. I push E, I could get two different things. If it's not predictable in that way, it cannot be a function. And again, I have two places where one in goes to two outs, which is a violation of what we said to be a function. It's got to be one-to-one. So here we have a great example of what a function should look like. Now, not everything is used, but if you look, there's only one choice. Every time I push a button, it's only going to give me that one thing. That's the idea. That's the ideal version of a function. One in will always just give me one out, no matter what. No repetitions. No one button going to two things. That, ladies and gentlemen, is how you can tell it's a function.